Welcome back to the session of geometry. In this session we are going to discuss the circles and the mensurations. Let's start with the circle first of all. Let's say if this is a circle. So we all know that the area of the circle is equal to pi r square and the circumference is equal to 2 pi r. Let's say if this is the center of the circle O. And if I draw these two lines, let's say this angle is theta. So this particular OAB, this part is known as the sector of the circle, and the area of the sector is always equal to theta by 360 into pi r square. And here I am taking the minor sector, which is OAB, or we can say that is AOB. Now similarly, this is the area of the sector. Now if I need to find out the length of the arc, for example, I need to find out this particular length. So the length of arc is equal to theta by 360 into 2 pi r. Now if I join the point AB, this entire circle will be divided in two segments. This is the upper segment, or you can say major segment, and this is the minor segment. So let's say if I need to find out the area of this particular, this is minor segment. So area of segment is always equal to area of sector minus area of triangle AOB. Now here the area of the sector we know that is equal to theta by 360 into pi r square. So straight away we can say, which is theta by 360 into pi r square minus area of this particular triangle. If the radius is r, we can say the area is nothing but half r square sin theta. So these are the certain basics of the circles here. Now let's start with the different properties of the circle. The first thing here is, if this is a circle and if I draw a chord AB, this is a chord AB, this is the center of the circle. If I draw a perpendicular from the center to the chord, this will always bisect the chord, or vice versa. If you draw the midpoint of the chord to the center of the circle, then this line is nothing but it is perpendicular to the chord here. Similarly, if there are two chords of equal length, for example, this is the chord AB and this is chord CD. And let's say the length of AB is equal to CD. Now, if the length of the chords are equal, then the perpendicular drawn from the center to these chords are also equal. So, if this is OX, this is OY. So, this also implies that OX is equal to OY, or vice versa. If the length of these two perpendiculars are equal, then we can say that the length of these two chords are also equal. Let's move to the second property. Let's say this is a circle and this is the chord AB. Now, if this chord AB subtends, let's say the angle theta at the circumference, then this angle will be also theta. So we can say that the angles subtended by the chord AB at the circumferences are always equal. Even if I draw a third angle, that will be also equal. Now, if we remove this line, so can I say this is nothing but the chord AB, but this is the sector AB? We are getting this AB as a sector here. This is the sector. So we can also say that the sector AB, angles subtended by the sector at the circumference are always equal. Or in fact, we can say that all the properties which is valid for chord, it is also valid for this sector here. Now, in case if I say there were two chords of equal length. Let's say there are two chords of equal length. This is chord AB and this is chord CD, and these two lengths are equal. So the angles subtended by these two chords are also equal. So always remember that the angles subtended by equal chords at the circumference are always equal, or if these two angles are equal, so we can say that these two chords, the length of these two chords are also equal. Let's move to the alternate segment theorem. Now what happened in case of alternate segment theorem? If this is a circle and if I draw one tangent here, let's say the center is O or anywhere, if from this point of contact, if I draw a one line segment inside the circle, now if this angle is theta, then the angle in the alternate segment, remember that this is the alternate to this particular angle, so angle in the alternate segment is also theta. All the angles in the alternate segment is always theta. Similarly, if I say, let's say this is alpha, if this angle is alpha, so if this angle is alpha, then angle in the alternate segment, so if this is the segment, so I can say this angle is also alpha. And this is one of the important property of the circle which we can use in the lots of question in fact. Now let's move to the property of the secant and the tangent. Now if I draw two secant and these two secant intersect outside the circle, let's say this point is P, this point is A, B, C and D. So one of the important properties is that PA into PB is always equal to PC into PD. The second important thing here is, for example, how to find out the measurement of this angle. Let's say angle P. So the other thing is also important, that angle P is always equal to half of measurement of arc AC minus measurement of arc BD. Now what do you mean by term half of measurement of arc AC minus measurement of arc BD? Now it is nothing but measurement of arc AC means angle subtended by this arc at the center. Let's say if this is the center of the circle and this is my arc AC. So we need to find out what is the angle subtended by arc AC at the center. Let's say this angle is theta 1 and angle subtended by arc BD at the center. So if this is the arc BD, so the angle subtended by this arc at the center, let's say this is theta 2 and this is my center O. So here we can say this is equal to half of theta 1 minus theta 2. Taking the second case, if these two lines intersect internally or inside the circle, for example, let's say like in this way, if this is say A, B, C and D and this is point P. So the first property is also true here, that PA into PB is always equal to PC into PD. Now, and also the measurement of angle P, we are talking about this particular angle, is here half of measurement of arc AC plus measurement of arc BD. And here also I need to take the central angle, angle subtended by arc AC and BD at the center. So for example, if this is the center of the circle and this is my arc AC. So angle subtended by arc AC at the center, let's say this angle is theta 1 and arc BD at the center. Let's say